Here you see these three are successive numbers. Product of three successive numbers. Now on the right side we have 16. Now you may think that we first multiply these three and get an equation which is cubic equation. The second one is connected with the first one. Then if the first operation can be performed in n different ways, and following that the other operation can be performed in n different ways, then those two operations can be performed totally n into n ways. Welcome to btosacademy. Welcome to my maths class. Today I am going to start new chapter. Name of the chapter is permutation combination. I start already I have written in the part A. I shall discuss the symbol named factorial and its meaning. This is a new symbol to you and an important symbol which is used in mathematics starting from 11th standard, factorial symbol. The symbol is this one, or this is angle like, and this is note of exclamation type. We read factorial x. Factorial x meaning is that successive product of 1, 2, 3 up to x, or in reverse order we can write x into x minus 1 into x minus 2 3 into 2 into 1. Factorial x meaning is product of successive integers or natural numbers starting from 1 up to x. Now it is clear factorial 1 will be 1, factorial 2 will be 2 into 1, two into 1, if we multiply 2, factorial 3, that will be equal to 3 into 2 into 1, value is 6. Factorial 4 will be 4 into 3 into 2 into 1, which is 24. Also we note here factorial 4, if we keep aside this 4, then 4 and this product is factorial 3. That means we can write factorial 4 is equal to 4 factorial 3. Now we can write the generalized form factorial n is equal to n you can take it as formula. Then factorial 0 is taken to be 1. This is the definition. In the later part, I shall discuss why it is required to take factorial 0 equal to 1 and factorial of negative number and fraction undefined as per the definition of factorial x. Next we have a few examples for you students or learners to have concrete idea of factorial related matter. Number 1, let us calculate factorial 9 by factorial 5 into factorial 3. Now we can write complete expanded form, or we can use this result or formula. Since at the denominator we find factorial 5, factorial 3 are there, I write factorial 9 like this, follow. 9 into 8 into 7 into 6 into product of the remaining up to 1, that is nothing but factorial 5. Factorial 5 into factorial 3 is there, therefore that is 3 into 2 into 1. Now it is easy to calculate. 3 into 2, 6. Sorry, sir. Wrong calculation. Okay. Value is 504. Now I take next one, factorial 12 minus factorial 10 divided by factorial 9. Now we see at the denominator factorial 9, therefore I write factorial 12 like this, 12 into 11 into 10 into factorial 9. Now factorial 10 can be written as 10 into factorial 9 divided by factorial 9. Now factorial 9 is common factor. Already I have told that when you are following these classes, you take pen and you copy and you start calculating or working out the sum which I am working out. You see the calculation in case of factorial 12, since there is factorial 9 at the denominator, if I express both of these keeping factorial 9, then factorial 9 will be common factor, then follow this one 12 into 11 into 10 into factorial 9. Now product of these 3, 12, 11 and 10. These two are cancelled, therefore result is 1, 3, 1, 0. Now example 3. We are going to express the given product using factorial notation. First one is 5 into 6 into 7 into 8 into 12. First you note the product is starting with 5 and successive numbers up to 12. Therefore, if I add here the product starting from 1 to 4 means this one 1 into 2 into 3 into 4. Next this one 5 into 6 into 7 into dot 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 into 12. Then we have to divide it by this product. Now this is nothing but factorial 12, therefore this is factorial 12 and this is factorial 4. Therefore I have expressed the given product in terms of factorial symbols. This is the answer. Next, example 4. Product of 3 into 6 into 9 into 12 into 15. We have to express this result using factorial. Now, we see 3 can be written as 3 into 1, 6 can be written as 3 into 2, 9 can be written as 3 into 3, 12 can be written as 3 into 4, 15 can be written as 3 into 5. Now you see each group contains 3 as a factor. Therefore, I first take all the 3. How many groups are there? 1, 2, 3, 4, 5. Therefore, 3 to the power 5 is taken first. Into product of the other factors, that means 1 into 2 into 3 into 4 into 5. Therefore, this is 3 to the power 5 into factorial 5. The problem was we had to express this product using factorial symbol. Therefore, I have expressed using factorial symbol. Therefore, this is the answer. Now, next example. To express factorial n into n plus 2 as sum of two factorials. First I write this expression factorial n into n plus 2. We shall use here this formula. This can be written as factorial n into n plus 2 can be written as sum of n plus 1 and 1. Why I have taken n plus 1? Because here it is factorial n. If I multiply that by n plus 1, then I shall get factorial n plus 1. That is why sum of two factorials. I think you can follow easily. Now example 6. We are going to find the value of this one when n equal to 15, r equal to 12. First of all, I shall put the values of n and r in this expression. Now, n factorial by r factorial into n minus r factorial is equal to 15 factorial 12 factorial into 15 minus 12 means 3 factorial. One thing for learner students, while you are using note of exclamation type symbol, be careful. Sometimes you may miss this dots, then there will be a gross mistake. That is why I prefer that angle like symbol of factorial. Okay, be careful about that. That is equal to 12 factorial is there, and at the numerator 15 factorial. Therefore, I write 15 factorial as 15 into 13, 15 into 14 into 13 into 12 factorial. You can mention in the initial part as since n factorial equal to n into n minus 1 factorial divided by factorial 12 into factorial 3 means 3 into 2 into 1. We need not write that 1. Okay, then these two cancelled. 3, 5, 2, 7. Now the value. I always suggest my students that you do rough work or calculation, that may be small or large, on the right side of the sum concerned. You see, I have calculated on the right side, then I have written. Students who will have the facility of using calculator, they can use the calculator and write down the value directly. Okay, then let us move to example number 7. Given n plus 2 factorial is equal to 60 into n minus 1 factorial. To find the value of n, I write like this first: n plus 2 factorial 60 into n minus 1 factorial. Since n plus 2 is greater than n minus 1, I write this as n plus 2 into n plus 1 into n into factorial n minus 1. I have used this formula, is equal to 60 into factorial n minus 1. Now you see, we can cancel easily n minus 1 factorial from both sides. Then this is n into n plus 1 into n plus 2, that is equal to 60. Now one thing I must discuss here. Here you see, these three are successive numbers. Product of three successive numbers. Now on the right side we have 60. Now you may think that we first multiply these three and get an equation which is cubic equation. Then it will be time taking to solve this equation. That is why you follow the trick which I am discussing here. Product of three successive numbers. We first expressed as 60 as product of three successive numbers. Follow that. Sixty 3 into 20. 20 is equal to 4 into 5. Therefore, we can write it 4 into 5 into 3. If I take that at first, then it is 3 into 4 into 5. On the right side also, product of three successive numbers. 3 is the smallest one. On the left side you see n plus 1 is greater than n, n plus 2 greater than n plus 1. Therefore, value of 3 will be 3. Value of n will be 3 in this case. Try to understand this trick. If we get product of three 2 or 3 or 4, 5 like these successive numbers. And the right side can also be expressed as product of 3, 4 or 5 successive numbers as the case will be. Then we can write directly value of the smallest one will be the smallest number on the right side. Therefore, n equal to 3. This is very important. Next sum. Example 8. 1 by factorial 8 plus 1 by factorial 9, that is equal to x by factorial 10. We have to find the value of x. X by factorial 10. Since the unknown is on the right, I have taken that on the left side. Then we have to simplify this. As 9 is greater than 8, therefore I express factorial 9 as product of 9 into factorial 8. Therefore, LCM will be 9 into factorial 8 9 plus 1 or x by factorial 10 is equal to 10 by factorial 9. Therefore, x is equal to 10 into factorial 10 by factorial 9. Now factorial 10 can be written as 10 into factorial 9 therefore x equal to 100. Very interesting sums related to factorial symbols. Next, I take next example. If factorial n by 2 into n minus 2 factorial and n factorial divided by 4 factorial n minus 4 factorial are in the ratio 2:1. I express that in equation form like this: n factorial divided by 2 into n minus 2 factorial divided by n factorial by 4 factorial into n minus 4 factorial. Ratio of these two is 2:1, that means 2 by 1 as per sum. This we have to find the value of n. Follow the steps. First of all, n minus 4 factorial. This one will be taken at the numerator part. Factorial 4 factorial divided by 2 into n minus 2 factorial. Now these two n factorial will be cancelled. I have not written that. Is equal to 2, or since n minus 2 is greater than n minus 4, that is why I keep this intact. N minus 4 factorial into 4 factorial means 4 into 3 into 2 by 2 into n minus 2 n minus 3 into factorial n minus 4 is equal to 2. I have used the formula n factorial. Better you mention n factorial equal to n into n minus 1 factorial. Now we simplify. These two are cancelled, or also we can cancel these two. Therefore, n minus 2 into n minus 3 is equal to 2 into 3. Now you see the left side is product of two successive numbers. Also right side is product of two successive numbers. Now n minus 2, n minus 3. Which one is greater? N minus 2 will be greater. I write this in reverse order. Therefore, using that idea, if we can express left side as product of two or more successive numbers and right side also as product of two successive numbers, then we can take the lowest of the left is equal to lowest of the right, or greatest of the left is equal to greatest of the right. Therefore, n minus 2 is equal to 3. From that, n equal to 5. Now you see, in the initial stage, in this case, you can find also the value of n in this way, alternatively. We multiply the expression on the left, n square minus 5n plus 6 is equal to 6, or n square minus 5n equal to 0, taking n as common factor. Therefore, n equal to 0 and n minus 5 equal to 0 will give you n equal to 5. See this process. Now if I take n equal to 0, then we will have n minus 2 factorial as well as n minus 4 factorial. For n equal to 0, n minus 2 means minus 2, but for n equal to 0, n minus 2 minus 2, that is less than 0. Therefore, factorial n minus 2 is not defined. Therefore, n equal to 0 is rejected. Therefore, n equal to 5. For this, we can solve, and solving in this way, actually framing equation, we will have more than one values. After getting those values, we have to check whether those values are satisfying the original value. Here we see n is not satisfying in case of n equal to 0, therefore n equal to 5. That is why I suggest my student use this trick. Product of two successive numbers on the left is equal to product of two successive numbers on the right. From that we can write easily this one. Also, if you take here n minus 3 equal to 2, from that also you will get n equal to 5. I think you have followed this one. Next sum, we have to show this sum means factorial n plus 1. This is not divisible by any natural number starting from 2 to n. Follow the solution. First, we write factorial n, that is the product of successive numbers starting from 1 to n, which is divisible by any number starting from 2 to n. Now if I add 1, here you have to be careful about the logic. This is divisible by any number starting from 2, any natural number or integer starting from 2 to n. Now if I add 1, therefore it is easy to conclude that this number, this one, is not divisible by any of 2 to n. Of course, integer. Why? Plus 1 is there. That means if we divide this number by any of the digits starting from 2 to n, then remainder will be 1 since plus 1 is there. From this result, from this it is clear if we define factorial n plus 1 by any of 2 to n, then remainder will be 1. Hence, factorial n plus 1 is not divisible by any of 2 to n integers already I have discussed about the basic things, also worked out few problems based on factorial symbol. Then I move to in my version it is part B, that means permutation combination method. First of all, we have to discuss the fundamental principle of counting, also some say fundamental principle of association. Let me first discuss, then I will give the formal definition. Say two or three actions or activities or operations which are performed successively, then the fundamental principle of counting says that the activities or the actions can be carried out or performed totally into m into n into p or some more numbers ways. First, let me give an example. I want to go to the Howrah station. Starting from the place where I am taking class. If I call this place as R, then to go to Howrah station, we have to go to Godia first. I express that by this diagram. First, I am to go to R to G, then going there, we have to go to H. Now, I can go R to G, say with the help of four vehicles, say auto rickshaw, taxi, bus, etc. Four ways. Then reaching Godia, we can avail say 6 ways. Then totally in how many ways we can move from R to H? You see, for any of the four ways to reach G from R, we can avail 6 ways. Then totally or total number of ways of reaching R from H will be 4 into 6 ways. Remember, G is the common place here. Now I explain the statement, fundamental principle of counting or fundamental principle of counting. If an operation, this is an operation or activity, can be performed, I write, if an operation can be performed or carried out in n different ways. And following that, another operation can be performed in n different ways. Then the two operations can be performed totally in n into n ways. Already I have explained the matter with the help of this example. Therefore, say there are two operations. The second one is connected with the first one. Then if the first operation can be performed in n different ways, and following that the other operation can be performed in n different ways, then those two operations can be performed totally n into n ways. This is the fundamental principle of counting. This is multiplication case. Case 1. Now there is second case, case 2. This is addition case. I mentioned that this is stated like this: if two events occur exclusively in exactly m ways and n ways respectively, then either of the two events can occur in n plus n ways. In the first case, after the performance of the first activity, the second activity will occur. But in the addition case, two activities are exclusive. That means one is not dependent on the other. That is why if the first operation can be performed in m ways and the second operation can be operated or performed in n ways, then either will be performed totally in n plus n ways. Now to explain this one, I take this example. There are 6 books on physics. 6 books on physics and 5 books chemistry. In a bookshop. Now the matter is, in how many ways can a student purchase either a book on physics or a book of chemistry? A student wishes to buy a book either of physics or of chemistry. Now if he buys physics book, then he can do that in 6 ways, and if he wishes to buy chemistry book, then he can buy in 5 ways. Since these are exclusive, therefore total number of ways of buying any of physics or chemistry book will be 5 plus 6, 11 ways. Follow this, students. Exclusive cases. That means buying chemistry book is not dependent on physics. That is why in this case addition is to be applied. And the last thing I have to mention, in case of multiplication, if I have described here two operations, there may be n number of operations. That means more than two operations. Then total number of ways those can be done. You have to take the product of the number of ways in which the successive operations can be carried out, performed. Now I shall discuss one sum that is based on the concept of the fundamental principle of counting. First of all, let us read the sum. There are 12 stations on a railway line. How many different kinds of tickets of second class must be printed in order that a passenger may go from any one station to any other? First of all, let me draw this diagram. I call this station as S1, second station S2, S3, S12. 12 stations are there. Now, a person wishes to start from any of the 12 stations, then how many types of tickets are to be printed? That means we have to consider any of the 12 stations. That means 12 ways to go to any of the 12 stations from say S1. First station, 12 kinds of tickets are to be printed. Now from station 1, first station, you can move any of the remaining 11 stations. That means the person will move to any of the remaining 12 minus 1 stations that is 11 stations. That means after reaching one station, he can move any of the 11 stations. If he starts from S1, then he can move or go any of the 11 stations. Therefore, totally 12 into 11 kinds of second class tickets are to be printed. Therefore, totally 132 kinds of tickets are to be printed. Now I move to the main thing, permutation and combination. I will discuss side by side. On the left side I have taken permutation, on the right side combination. Synonym for permutation is arrangement. And synonym of combination is selection. I take example to discuss different things. First of all, we consider different things. We take as A and B, two letters. In this case also, two letters. Now, taking these two letters, the arrangements will be AB, BA. If I write A first, then B, then we get one arrangement. If I write B first, then A, then we get other arrangement. That means we are getting two arrangements. From it is clear that order is considered order matters. I say like this. But in case of selection, if I take AB or BA, one selection, Whether A is taken first or B is taken first, no matter. Selection. That is why one selection, you see. But here two arrangements. Then we take three objects. We are choosing three letters. Of course, different. Then, in case of selection or combination, also three letters. Now, uh, we consider all three letters are taken together. Then, arrangements will be A, B, C. Then, keeping A fixed, A, C, B. Then, B, A, C, B, C, A. Keeping B first. Then, C is kept first, C, A, B, C, B, A. How many arrangements we are getting? 1, 2, 3, 4, 5, 6. You may put brackets like this. How many arrangements then totally? 6 arrangements. But in case of selection of these three letters, order does not matter. Therefore, whether it is ABC or ACB or BAC or BCA or CAB or CBA, same, because order does not matter. That means selection is one selection. Taking three at a time. Taking three letters at a time. Now we consider out of these three, we are taking two at a time. Out of three, taking two at a time. Then arrangements will be like this: AB, BA, BC, CB, AC, CA. First A, then B, then we reverse BA, then first B, then C, reversed CB, then first A, then C, reversed CA. That means how many elements we are getting? 6 elements. Now in case of combination, 2 letters, 2 things, 2 objects out of 3 objects. Let us consider first AB. These two will give just one selection, means one selection. Then AC, CA, again one selection. Order does not matter. Then BC, CD, one selection. Then totally how many selections? Thus, in case of permutation arrangements, positions, about positions, if two objects are taken, then changing the positions, we are getting different arrangements. But in case of combination or selection, change of position, that is, order does not matter. Now, we use the symbols. In case of permutation, in this case, two different objects are there. We are taking two at a time. We express that two P2, two P2. Out of two different things, taking two at a time, number of arrangements, that is expressed by this symbol. I repeat, out of two different things or objects, we are taking two at a time and arrange. Total number of arrangements will be 2P2. This is the symbol P for permutation. In case of combination, out of two, we are taking two at a time. The number of combination is represented by the symbol 2C2. C for combination. Now, this case, three objects are there, different objects of course. We are taking two at a time. That is represented by the symbol 3P2. And here it is 3C2. The topmost number indicates total number of objects, different objects of course, and the lower number indicates you are taking those numbers of objects. In case of permutation, you are arranging. In case of combination, you are selecting. Then symbols are discussed here. Now, if we take all three objects, in case of permutation, it will be 3P3. And in case of selection, it will be 3C3. Now, let me write the values. Given n different things, objects, articles, if you take R objects at a time and arrange total number of arrangements is represented by the symbol NPR. I shall discuss later. The value will be factorial n divided by factorial n minus r. After discussing this, I shall discuss how we get the value of NPR. Now, in case of combination, the total number of selection is represented by NCR and value will be factorial n divided by factorial r into factorial n minus r. Students, you follow this. I have discussed here side by side. I think it will be easier to understand. Out of n different things, articles or objects, we are taking R at a time and arrange. Now total number of arrangements will be this and total number of selection, that is combination, will be this. Also there are different symbols used. In case of NPR, it is also represented by this symbol. NPR, this symbol is also used. Sorry, this is not not this one. This symbol is used also. This symbol is used, and in case of selection or combination, other symbol is now. I am going to discuss the permutation case. First of all, permutation case. Out of n different things, taking r things, total number of arrangements. Try to understand. There are n different articles. We have to take our articles at a time and we have to arrange. Then we have to determine how many such arrangements will occur. Now this problem can be stated like this also. N number of marbles are there, and there are holes. R holes are there. We have to fill these holes taking R marbles together. Of course, R is less than equal to N. Now let us try to understand in this manner. From N marbles, we can fill the first hole in how many ways? The answer is automatically in N ways. First hole can be filled in N number of ways. Now after filling the first hole, number of marbles you have N minus 1. Then second hole can be filled in how many ways? Out of those remaining N minus 1 holes, automatically in N minus 1 ways. I write here like this, N ways, then N minus 1 ways. Now, try to understand carefully. Filling the first hole in one way, the second hole can be filled in N minus 1 ways. Therefore, considering N number of ways of filling the first hole, two holes can be filled totally in how many ways? Following the Inequality method. Filling in one way, second one is filled in N minus 1 ways. Therefore, the first hole is filled in N ways. Therefore, total ways will be N into N minus 1 ways. Now, after filling the second hole, you have N minus 2 marbles. Now, the third can be filled in N minus 2 ways. Therefore, following the similar argument, the first three hole can be filled in totally N into N minus way, N minus 1 into N minus 2 ways. Now, following this argument, we can conclude that these R holes can be filled in totally in how many ways? N minus 0, N minus 1, N minus 2, dot dot dot. Try to understand. Very interesting. Total number of filling R holes by R number of marbles taken from N different marbles will be this one. You see, I have written the first factor N minus 0. That means 1 less than whole number. HONE, whole number. The second one, n minus 1, I can write this as 1 minus 1, this one as 2 minus 1, this 3 minus 1. Second whole 2 minus 1, first whole 1 minus 1, third whole 3 minus 1. Therefore, for rth whole, it will be n minus, within brackets, r minus 1 ways. Therefore, total number of ways of filling r holes is equal to n into n minus 1 into n minus 2 dot 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 n minus r plus 1. If I remove this bar bracket in column, it will be this one. And already I have discussed, if you arrange r articles out of n different articles, total number of arrangements is denoted by the symbol NPR. Therefore, it will be NPR. Now, using the concept of factorial symbol, already I have taken few problems. This one can be expressed as product of these to express this in factorial form. I have multiplied this one at the denominator as well as at the numerator. Therefore, we get this one in factorial symbol is factorial n. This one in factorial symbol is factorial n minus r. Therefore, NPR is equal to this one. Thus, let me sum up. If n different things are there, taking r things at a time, if we arrange, total number of arrangements will be in symbol NPR, and its value will be n into n minus 1 into n minus 2 dot 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 n minus r plus 1. If we express that in factorial form, that is equal to factorial n divided by factorial n minus r. Thus, in this episode, I have discussed basic things of permutations and combination. In the next episode, I shall discuss other theories related to permutation and combination. Thank you.